Okay, so in this video, we are going to solve this question over here. We have an equation with logarithms, and they want us to solve it and express our answer, which is basically x, in terms of ln 3. Because they say they want the answer to be in terms of ln 3, this gives us a hint that we need to use change of base. Okay, so change of base is required. Okay, why is it required? It's just because I have a log base 2 over here. The log base 2, I don't want that. I want ln, right? So let's start off with that. Let me write down the equation first. And then, okay. And then we are going to change the base into log base e or ln. Okay, so the first thing I'm going to do is change the base. So I'll just duplicate this. And over here, this one last term here, I'm going to change the base. I'm going to write a fraction. I'm going to take note that I have base 2 down here. I also have a bunch of stuff, 16 to the power of something up here. So the stuff on top, which is the stuff in yellow, will be up here. 16, 1 minus 2x. 2, which is the base, goes below. Now I can choose, technically speaking, I'll just write a logarithm here. I just need to choose the base. However, I want to choose base e, which is just written as ln. Okay, now I want everything in terms of ln 3. Or not everything, but I want x in terms of ln 3. It seems a little bit weird that I have a ln 2 over here. But the good thing is that it will settle itself. It will go away on its own. So what I'm going to do now is I realize that I have a 9 and a 16, right? These numbers are, we can write them as like 3 to the power of 2, 2 to the power of 4. So let's write them as such. And we will get ln 3 5x plus 1 equals to ln 3 to the power of 2, but then we still have the power of x plus 5. Okay, and then on top here we have 2 to the power of 4, to the power of 2 to the power of 4, and then power of 1 minus 2x. So actually the powers will multiply. Okay, so we get this. The next thing we can do is we can bring out this power over here. Okay, this power over here, we can bring it outside of the logarithm, and then the ln 2 over ln 2 will cancel out. Okay, so let's do that. Second thing is we're going to minus over, right? Subtract over. I'll bring this ln 3 over to the other side. Okay, so what I'll get is ln 3 5x plus 1 minus ln 3 2 times x plus 5 plus I will bring out the 4 times 1 minus 2x, and then technically speaking there's a ln 2 over ln 2, but it cancels out, it becomes a 1. So I'll just erase this. Okay, now that we have this, when we have logarithm minus logarithm, let's recall that actually wait a minute. Right, I subtracted over, so this should be an equal sign. Yeah, okay, but let's recall that when we have logarithm, okay, log base something a minus log base something, okay, log base something b, okay, this is actually log base the same base, but it's the first guy a over the second guy b. So we can write this as ln 3 to the power of 5x plus 1 over 3 to the power of 2x plus 5. 2 times x plus 5. Then this is 4 minus 8x. Okay. At this point, what I can do is, what I'll do is actually to exponentiate both sides. But I think before that, let's just deal with this fraction here first. So I have ln, and inside this I have 3 to the power of something divided by 3 to the power of something. I can write this as 3 to the power of the the power of the one in the numerator minus the power of the 3 in the denominator. So I get something like this. Let me move things around a little bit. Okay, yeah, I get something like that. And then the right hand side is still the same, 4 minus 8x. Okay, I have ln something equals to some number. I want to get rid of the ln. Okay, I want to get rid of the ln. What I'm going to do is I'm going to take 3 to the power of everything. 3 to the power of both sides. So if I take 3 to the power of both sides, oh wait, sorry, I don't need to get 3 to the power of both sides because I'm allowed to have ln 3. I can bring out this power in front and we will get 5x plus 1 minus, let's just expand the bracket while we are at it. So minus 2x minus 10. And then ln 3 equals to 4 minus 8x. What I want to do is I want to actually expand this bracket. Okay, I need to simplify this first, expand, bring all the x's to one side, bring all the numbers to the other side. Okay, so let's do that very quickly. We have 5x minus 2x, so we have 3x. And then I expand, I get ln 3. I have 1 minus 10, so negative 3 times ln 3. Okay, afterwards I'm going to bring all the x's to one side. So I'm going to bring the 8x over to the left side. I'm going to bring the 9 ln 3 to the other side, so plus 9 ln 3. I will factorize out the x. I get 3 ln 3 plus 8 equals to 4 plus 9 ln 3. Okay, now everything else are just numbers, so I'm just going to divide by that bracket on the left hand side. Okay, so I'll get this fraction and I'm done. Okay, so I'm allowed to have ln 3. Actually, ln 3 is just a number, so even if they say they don't want it to be in terms of ln 3, I can just type it into the calculator. Okay, let's move on to part B. Okay, so part B says to solve this equation here. This equation here, I have two different bases. So again, I have a hint that I should use change of base. Okay, so whenever you see two different bases, typically speaking, change of base, we try to do it as soon as possible so that everything is nice, we can manipulate things more easily, right? So let's just change the base first. Let me copy out the equation. Sometimes, okay, to be honest, when I was a student, I am quite lazy to copy out the equation. So I'll just jump straight to the next step, basically. But I think it's a good practice to just copy out the equation first, right? So after I copy out the equation, what I'm going to do is I'm going to write the equation exactly the same, okay? Except for this one term that I'm going to change the base, I will write a fraction, okay? And I'm going to write logarithm, okay? The stuff that is a little bit lower, which is the base, is going to go downstairs, okay? Lower. The stuff that is a little bit higher because it's not a subscript, this x minus 3, the argument, this is going to go upstairs, x minus 3. Okay, so we need to put this like bracket, this parenthesis here, so that we know that this x minus 3, these two things are actually inside the logarithm function, right? If we omit this bracket, it will look like log base something x, then minus 3. Minus 3 is outside. So this bracket is quite important. Now that we have written out like this, we can choose any base we want to change it to. In this case, I want the number 2. So let me just change to base 2. And this denominator is actually log base 2, 2 squared. I can bring out the squared. So what I'm going to do is I'm just going to cheat a little bit because I'm using iPad. I can duplicate things. And I'm going to write this as 2 to the power of 2, but then the power I'm going to bring outside. And then log base 2 is actually equals to 1. Okay, let me write that in blue, because I probably wouldn't write that in exam. You can if you want to, but these are just like notes. Alright, so I actually have log base 2 something divided by 2 times 1 or divided by 2. So what I'm going to do is I'm going to multiply by 2 throughout. Okay, so if I times 2 throughout, I will get log base 2 x minus 3 plus 2 log base 2 2x plus 1 to the power of half equals to 2. And then the next thing I'm going to do is actually to take this 2 in front here, I'm going to multiply to the half. So actually it will cancel out. So I'm just going to cancel like this. So I don't have to write it again. Next thing is I have log, same base, okay, log plus log. So the argument will multiply. Okay, so we recall, okay, that when we have log base something, doesn't really matter what it is, okay, of a certain number, let's say log base squared a plus log base squared b, right? Whatever the square is, you can just treat it like a blank, okay? What will happen is that I can merge them together into one logarithm, and this will be a times b. Okay, so let's do that. Okay, so we have log base 2 of x minus 3 times 2x plus 1, okay, equals to 2. Now, the next step that we can take would be to just raise everything. I'm gonna exponentiate both sides. Okay, that's one way of calling it. Let me put this recall on the left side, so we have a bit more space. Okay, so what I'm gonna do is I'm going to exponentiate both sides. Essentially, I'm just gonna write this raise, like left hand side, I'm gonna put 2 to the power of left hand side equals to 2 to the power of right hand side. The left hand side will have 2 and log base 2, those will cancel out. I essentially take out this thing and it's equals to 4. So it becomes just an algebraic equation to solve. So I have x minus 3, 2x plus 1 equals to 2 squared, which is 4. So let's expand the left hand side. Okay, I'll just do it quickly. Okay, we get this. Then we are just going to simplify, and I'm going to bring the 4 over as well, so I get this. From here, we can try to factorize. If you don't feel like factorizing, what you can do is you can just immediately use your quadratic equation or your calculator to solve it. But this is simple enough to factorize, so let's just practice. So over here, we're going to open 2 brackets, put it equal to 0. The first term is 2x squared. This will be 2x times x. We can think about the 7. 7, if you decompose it into its prime factors, it can only be 1 times 7, right? So it's either 1, 7 or 7, 1. In this case, it should be 7, 1. And it should be minus plus. Okay. This is simply just kind of like guess and check. You just guess what's inside the brackets, and you just expand it out in your mind to check. So this is the correct way to factorize. Anyway, you can expand it out to check if you want to, but just trust me for now. So this will be x equals to 7 over 2 or x equals to negative 1. So now when we get something like this, when we get like multiple answers, actually not just for logarithms, it's just that for logarithms it's especially important because usually we need to reject certain solutions. So the best thing you can do here is to just eyeball it. You have 2 different x values. You're just going to sub it into every single logarithm term you have in the original expression. Okay, don't care about your own working. Usually it doesn't really matter. Just sub into the original equation, right? So if you have 7 over 2, that's 3.5. If I sub into here, 3.5 minus 3, 0.5, nothing is wrong, right? It's just a number, doesn't really matter. So 3.5 you sub into here is a positive number, doesn't really matter. However, when you take x equals to -1 and you and you substitute it into the first logarithm term, so you have -1 minus 3, -4. Logarithms cannot take negative arguments, which means this second one should be rejected. Okay, and typically speaking, when you reject certain answers, you should give a short description or a short explanation of why you chose to reject it. So let me just write down that since log base 4, because that's the first term, okay, log base 4 x minus 3. So instead of x, I'm going to put in -1, okay, minus 3. Okay, this is undefined, right? This is undefined. So I'll write down that because it's undefined, that's why you reject x equals to -1. And the only solution here is 7/2. In A math, you can write it as improper fraction, decimals, mixed numbers. So I'm just gonna leave it like this. And that's it for this question.